Good morning. Thank you for joining us for part 2 of the webinar series on work zone traffic control. We have for you today Ray Brushart, who is the safety circuit writer for the Ohio LTAP Center and has extensive experience in teaching this topic and also applying it in the field. So I'm going to go over a few housekeeping items and then I'm going to turn things over to Ray. First off, the Ohio LTAP Center is attempting to record this webinar, and if we are successful, we will send out a link to the recording afterwards. Watching the recording, though, does not get you credit. You have to actually be here on the webinar live in order to get credit, so it's a good thing you joined us. We'll be doing some poll questions throughout the webinar, and if your screen will not record your answer for some reason, when the poll question's up, it's probably because you're in full screen mode. So you'll just need to hit the escape button at that point, and then it'll allow you to answer the poll question. Last but not least, there is a questions box in the GoToWebinar panel, and we encourage you to send questions in throughout the webinar. As you send your questions in, I will be waiting for Ray to take a breath so I can interject and get your question out there so he can respond to it. With that, I'm going to turn things over to Ray.
Well, good morning, everybody, and welcome to part 2 of our work zone traffic control and safety webinar and our series. In part 1, we went over, a lot of general information about work zone traffic control. For instance, we went over, some manuals and resources to find online. We became familiar with the Ohio Manual of Uniform Traffic Control Devices and part 6 of that manual, which is the Temporary Traffic Control Manual. And we talked about some crash statistics involving work zones. And what else did we talk about? We talked about signs for our advanced warning area, and got to know a lot about signs. Like, for instance, talked about sign spacing and the size of signs and sign retroreflectivity. And I think we have some questions to make sure that everybody grasps that. Let's do a little summary, a couple of questions to summarize, so make sure everybody, remembers that. How about that, Victoria?
Sure, Ray. Making sure everybody's awake this morning.
Yeah.
So, which question do you want?
Let's see. You've got a couple there about signs, right? Like size of signs and.
Yep, here. With the minimum size sign overview for high speed.
Sure.
I can launch that one. And again, remember, if you're in full screen mode, your system's probably not going to allow you to vote. So just hit the escape button and it'll take you out of full screen mode. I'm going to wait for hopefully 80% of you to put your responses in. And they're voting fast and furious. So
okay.
And we're getting answers all over the board. So this is going to be an interesting one.
Yeah, it's important to know about the details about working in high speed. And high speed begins at 45 miles per hour. And so
actually a lot of our local roads are high-speed roads by
that's
definition.
Right. Absolutely. So even cities, it's not just county engineers crews with their 2-lane 55-mile-per-hour rural roads, but city streets, a lot of them are 45. And so, when the crews are working on 45-mile-per-hour streets, it's a different situation than their 35-mile-per-hour. They need to
I'm going to
have
close
the bigger
this poll
signs
out.
Okay.
We've got our voting percentage. All right. Oh, goodness gracious. I clicked the wrong button. Hold on.
Uh-oh.
I know. I need some more caffeine this morning. All right. I'm sharing the results. So we have 38% that said 36 by 36, 35% said 48 by 48, 22% said 48 by 36, and 4% said 36 by 48. So what's the correct answer, Ray?
It's some trick questions in there. But these diamond-shaped signs, it's like they're square, really, but when you turn them about 90 degrees and they're diamonds, right? But it's actually 48 by 48. 4 foot by 4 foot is what you should be using when you're working in high speed. So,
do you want to do another question?
yeah, let's do another. Because we had too many too many missed that one.
All right, so here we go. Portable signs must be mounted on supports that elevate the bottom of the sign. How far above the traveled way?
Right, like the top of the pavement. How high above the top of the pavement should the bottom of the sign be?
Well,
And
the answers
we kind of went over that.
Yeah,
Okay.
you did, and you can tell it by the answers. So people were paying
they're getting
attention.
this
one. Yep.
Okay, so I mean, this class is really geared towards setting up work zones for local governments as they work on their roadway maintenance activities, roadway and utility infrastructure maintenance operations. You know, I know there's a lot of ODOT people taking this class, but you know, ODOT is usually working on. I mean, we have our own roadway maintenance activities as well, but we won't be getting into the ODOT long-term work zones.
Right. Okay, so we've got I closed the question out while you were talking, and the results are in. 86% chose 1 foot minimum, 11% chose 2 foot minimum, and 3% chose 1.5 foot minimum.
Oh, well, the answer is 1 foot minimum. And the reason for that is when you put your sign on that stand, then the message on the sign is at the optimum height for the like the eyeball of the driver in the car to read that message as they're driving. And so that's how they came up with that. A lot of studies you'll see in a lot of engineering drawings and things like that. They show a 3.5 foot tall. When something is 3.5 foot above the edge of pavement, or the height of the pavement, that they can read that message from quite a distance, and so that's how they came up with that.
All right, Ray. Well, I closed those responses out, so it's all yours now.
Okay, so some other stuff that we, talked about, some good resources that maybe you should have as you take this class, and one is the app. Told you to download our app for it's based on this little reference pocket guide here, guidelines for traffic control and work zone. So one of the main things out of this, of course, it has has several of the typical applications that we talked about, but for purposes of roadway maintenance activities, on page 17, we went over this top table on page 17. It's called, the table says recommended advance warning sign minimum spacing. So we talked about how important it is to space our signs properly. When we have a series of 3 signs, which a lot of the typical applications have, the series of signs, and it all depends on the type of road. So we talked about urban low speed, urban high speed, our rural roadways. We have a lot of 2-lane rural state highways, 2-lane rural county roads and township roads that are 55 miles per hour. So it's important to have those signs at 500 feet apart. And then we have, on our ODOT expressways and freeways, or some of these expressways and freeways are owned by cities, but here we have quite a difference in the sign spacings on so that's a lot about what we talked about in part 1. And now, as you can see, as I scroll down this page, there's 2 other important tables on this page. It deals with the spacing of channelizing devices, and so there is a difference in how we space our cones and drums on 2-lane roads versus multi-lane roads. And it talks about how we space these channelizing devices in the taper, and that's different from how we space the signs or the cones in the buffer and workspace. And then our bottom table deals with tapers. There's 4 different types of tapers. We have our what we call a flagging taper when we're setting up a flagging operation on a 2-lane road. The second column in this table says 2 lanes at the top here. So when you're dealing with a 2-lane road, they call it a max 2-way taper, and that's the taper we use in a flagging operation, which goes along with typical application number 10. And so this type of taper is not related, doesn't change with speed. It's a 50-foot minimum to 100-foot maximum. But then our other tapers are dependent on speed. So we have a merging taper, shifting taper, and shoulder taper. So as an example here, a merging taper, it goes along with like typical application number 33. So a 35-mile-per-hour taper is 245 feet. So if you're on a 4-lane city street, or 4 or 5-lane city street, you're closing the right lane. One of the options is to use typical application 33, and on a 35-mile-per-hour situation, you have a 245-foot merging taper. So merging taper is the longest taper we have. But if we're on a 55-mile-per-hour road, on a multi-lane road, you see it's 660 feet. And if you're on a 70-mile-per-hour expressway, that merging taper is 840 feet. And then the other thing to talk about on this table is on the far right column. It says buffer. So, we'll talk about the buffer space as one of the elements of a work zone. And we need to include this buffer space, sometimes referred to as a safety area, but it's it's also dependent on speed. The values in this column are equal to the stopping sight distance for a certain speed. So we'll get into talking about those. So, you can find these tables on the app as well. If you download the app and then click on those 3 lines at the top left corner when you first open up the app, and then scroll down to spacing, and then these tables pop up. Okay, so that was a lot of the stuff we talked about, little background reminders there. And so let's go ahead and move on. Do I see a question flashing there, Victoria? Let's see.
You do, Ray. It was just someone apologizing that they joined late.
Okay.
But you're good. Thanks for.
All right.
Yeah.
Okay, let me put this up to speed here. Okay, so the next thing we want to talk about is our different types of channelizing devices, whether you're using cones. There's several different designs of cones. We have our orange barrels and some other temporary traffic control devices that we're going to talk about. Like we said in part 1 is, you need to, the first step in your work zone design is to select a typical application that fits with the location and type of roadway that you're working on, and it'll show in the illustration. Remember, these typical applications are 2 pages. One's an illustration and one's the notes page that has the standards, guidance, and options. But in the illustration, you'll see, it'll show you what signs to use, and also show you the channelizing devices placement, with the tapers and how they're installed in the buffer space and the workspace and termination taper. So let's talk about these channelizing devices. What do they do for us? They direct traffic from one lane to another and guide travelers along a safe path. Some of these can be hazards themselves, so we need to make sure they're installed properly. And these you have your warning signs before the channelizing devices usually. And as you can see in this picture, our channelizing devices also have retro reflectorization for nighttime use, but also, with the latest standards in retro reflectivity, they really stand out during the daytime as well. So let's take a look at some pictures of other types of channelizing devices. So we see several different types of channelizing devices here in these pictures. We have our cones, we have tubular markers, vertical panels, drums, and the drum is what most people call the orange barrels, but those are the drums. And then we have barricades. So we can see some drums and the type 3 barricade in the picture on the right, and different types of these tubular markers, or grabber cones as they're sometimes called, that are 42 inches. Like this one here on the left is very skinny, and then they make them like the one on the far right, which is wider than that one. The wider the channelizing device, the better. And I always tell locals to not use the skinny grabber cones and the taper. You should use the fatter cones and the taper. That way they're seen more from a distance. So cones are the most common channelizing device used in short duration operations. We talked about work duration in part 1, but a short duration operation is during the daytime, 12 hours or less in length. And so when you're out there, and that's where most roadway maintenance activities take place. And so when you're using cones, you're supposed to be out there with the cones. If you're leaving a lane closure up overnight, then you should be using drums. So why are the cones so common? It's because, well, there's a lot of advantages to using cones. They don't damage vehicles that hit them. They're well recognized and understood, and easy to transport and store. But there are some disadvantages. They don't command as much respect as the drums do. It's easy for motorists to drive into your workspace, and easy to displace or knock them over. When I was at the city of Columbus, we had policies about when to use cones and when to use drums. And an example of that is if we had a lane closure in the downtown area, we never used cones, we used drums. And so that's because they got more respect, not just from motorists, but also all the pedestrians, maybe some bicyclists, and we would even hang signs on the drums because sometimes it's as we'll talk about later, sometimes when you work for the local government, it's kind of hard to figure out where to place your signs. It's easy to figure that out when you work for ODOT, because they always have nice wide shoulders. But sometimes when you work for a city or county or township, you don't really have those wide shoulders, or sometimes you have curb and gutter right up against a lane. It's nice if you have that grass lawn area between the sidewalk and curb and gutter, but like if you're working in a downtown area of a city, sometimes you have to remove parking and put your signs there. And an easy trick to placing signs is to hang them on a orange drum. And so that's what we did when I was at the city. So there's different specs for the height of cones. If you're using the cone shape on the right there, they make those in 18-inch heights for daytime low speed operations, like maybe if you're working in a residential subdivision where there's hardly any traffic whatsoever during the day, and and it's very low speed. But on any other street, I would use 28-inch. In fact, if it was up to me, I would never buy an 18-inch cone. I would always buy the 28 inches. And then those grabber cones I was showing you, the tubular markers, they are 42 inches in height. And all of these are retroreflectorized for night use, but also just to help them stand out during the daytime. You shouldn't be using cones that don't have the bands of retroreflectivity anymore. Here's an example of the old style of cone. So here's a work zone setup that goes along with typical application number 33. They're using these old cones. Some of them are very faded or covered in tar. And you can see they don't really stand out that much. But if you had the new cones, they really would stand out more. Okay. So, how about these cones? Are they acceptable for night use? The answer is no. They definitely need to have the retroreflectivity. So then we have our drums, and they do command more respect than cones, and they're more visible even from a further distance than cones. That's why ODOT crews use drums so much more often than the locals do. If we're on a 70-mile-per-hour freeway and we're setting up a long-term work zone, we definitely use our drums, not cones. But there's some disadvantages, like they are more difficult to install and store. Here's a nice drum, but I think this drum has seen better days, hasn't it? So is it acceptable? Well, you might be thinking, well, it does have the retroreflective bands, Ray, so isn't that all you need? Well, the answer is no. It has to retain that shape. Motorists need to recognize the shape of the drum, kind of like what we talked about, the shape of signs communicating a message in part one. A diamond-shaped sign is a warning sign. Well, people need to see the drum shape as well. They need to see that from quite a distance in the taper. That's why we looked at those tables at the beginning of this session, showed you about how the spacing of channelizing devices is different in the taper versus the workspace. That's because they need to be closer together in the taper so that it looks like a wall of cones across the lane from a distance. And we need to make sure our channelizing devices stay in alignment. That's why, if you're going to be out there for, well over an hour, between 1 to 12 hours, you need to routinely check on your signs and cones to make sure that everything is still in place. Then we have our barricades. So, a lot of times we close a street, or in our long-term work zones, we might use these. But these are basically used to outline construction areas, maybe on our long-term construction areas, or close a street. Some of these designs of barricades can be used for channelization or to mark hazards. As you can see, we can hang signs on them as well. So it's a very common thing to see type 3 barricades with a sign on it that say road closed or detours. And one reason for that is because there's at least 4 typical applications that deal with street closures or road closures. So there are actually 3 types of barricades. It all depends on the number of rails that you see on the barricade. So type 1 for low speeds, type 2 for high speeds, and that might be for channelization. But then we have our road closures. And so if you're closing a road with a barricade, you need the 3 rails, a type 3. And the stripes on a barricade actually mean something. It's kind of like if you're driving down a road and you're arriving at a bridge, and you might see the black and white stripes on the sides of the bridge as you approach on the parapets. And they're striped the same way as these barricades. So they are striped with the stripes sloping downward in the direction the traffic is to pass. Maybe if you're approaching a tunnel or a narrow overpass, or is it an underpass? Anyway, you might see stripes on both sides. that direct you to drive between those stripes. So if you're closing a roadway, you generally put two barricades together, like you see on the right, such that the stripes form a V, and then you could hang your sign on it that says road closed or detour. The one on the left means that you can drive on either side of those barricades. Like if you have an arterial street with 3 lanes in each direction and you're working in the middle lane, then you could set up the barricade like this. And a lot of ODOT vehicles and city work vehicles, they might have retroreflective striping on the back of their work trucks that are striped in this manner. So barricades, we have to remember that if a vehicle crashes into a barricade, it's going to damage the vehicle. And so we need to usually the proper warning before the barricade, especially if it's a high-speed roadway. Have our warning signs in advance, and then but that's also for why we weight the barricades down with sandbags, and the sandbags are placed at the bottom of the barricade. We do not weight our barricades down like this picture. So that might that's not a forgiving design, and as you can see, if you crash into that device, that concrete chunk's going to come flying through the windshield, right? So that's not the way to do that. Okay, so then for our long-term work zones, we might install vertical panels, or maybe where we have situations where there's not enough room for a full barricade. And then some other things you might see, some other devices include warning lights. We use these to make our devices more effective and to draw attention to our devices, and they supplement other traffic control devices. We actually have 3 different types of warning lights. Type A for nighttime use, and they're low intensity flashing at night. High intensity at night can blind the motorists. They're very, very bright. And type B is for daytime, high intensity flashing. What is a high intensity light? Well, a high intensity light can be seen from a half mile away. And then we have type C. It's not flashing, it's steady burning, and you'll see these in our long-term work zones attached to our drums for delineation. So in this picture here, if we were to guess type A, type B, or type C, as we can see, the picture is during the daytime, and it's on a warning sign to draw attention to it. So that's a type B. So it's high intensity flashing. And then when we happen to be working in what's called heavy urban traffic, we need some high-level devices and to supplement our other devices. So, if you work for a city, during rush hours and other situations, you're going to experience heavy urban traffic. And so we need devices like arrow panels, and you'll see portable changeable message signs have become a lot more common these days. And then portable traffic signals, and even I've seen portable automated flaggers on our more high volume 2-lane rural roads. So let's talk a little bit about our arrow panels. And so we use these in addition to our signs and channelizing devices. And as you're looking at your different typical applications, usually you'll see how to place them and which mode to operate them in. And so these are used to direct traffic into the proper lane. One place we never use arrow panels, and that's in a flagging operation. So here's the illustration from typical application number 10 for flagging. You'll see there are no arrow panels shown. Okay, an arrow panel would draw attention away from the flagger, and that would not be good. Let's take a look at some of these typical applications that show the use of arrow panels. And just kind of quickly here. So if we're going to, let me see if I can move this. Okay, so we have, if I was to go down to typical application number 17 that we talked about in part 1. Here it is on page 30 of the pocket guide. Let me zoom in on a little bit here. So you got, I keep having to move this thing. So it's showing a 2-lane road. It's a mobile operation, and they're showing the arrow panel. It's optional. That means it's the highest level of safety that you're adding to your work zone setup. So that's why ODOT crews are always trained to use the arrow panel on a mobile operation on our high-speed 2-lane state routes if they chose the mobile operation. It's shown in the caution mode. And so there's 2 different settings for caution mode. One is a straight line, but they don't want you to use a straight line. So they're clearly showing you the optional mode where the 4 corners are lit up. And so what that is telling the motorist approaching from behind, first of all, it's helping you to be seen from a distance. Secondly, as you can take a closer look at this road, you'll see dashed lines on this roadway. So that means it's a passing zone. But our ODOT crews are trained to, we don't combine flagging with mobile operations. So this mode of the arrow panel is telling them that it is okay to pass, but it's up to the motorist to decide when to pass. So we don't have our crews, somebody flagging behind there. Okay, now at the local level, when we get into talking about mobile operations, I'll show you that it is okay sometimes on your lower speed, lower volume roads to combine flagging with mobile. But then as we look at other typical applications, when we get to our multi-lane roadways, here we have a mobile operation on a multi-lane highway, then we can use the arrow modes here. So that's typical application 35. And then if we look at 33, then we have an example of a right lane closure on a multi-lane highway, and they're in arrow mode there. So it's placed at the beginning of the merging taper, protected by a shoulder taper. It's at the beginning of the transition area of the work zone. So those are examples of how the typical applications show you how to use the arrow panel, and they even depict it as whether it's optional or not. So in this case, it's not optional. It's a standard. Okay, so there's different sizes of arrow panels. For low speeds, you can use the 4-foot by 2-foot. Again, it's the lights on an arrow panel are high intensity, so they can be seen from a half mile away. And then for higher speeds and multi-lane roads, 96 by 48 inch. I get a lot of questions about that, but for locals, a lot of times on their utility trucks, like the big vac trucks that utilities use, some of them come equipped with an arrow panel, but is really small. It's like, I'd like to have a discussion with the manufacturers of these big vac trucks. It's like, if you're going to put an arrow, an attached arrow that lights up on the back, at least meet the standards.
Ray, we have a question.
Yes. Okay, let's go.
Why shouldn't you use arrows with flaggers? I thought less presentation mentioned arrows showing a merge direction. Maybe they mean last presentation.
No, you definitely do not use arrow panels in a flagging operation. So, like I said, it would draw attention away from the flagger, and then also an arrow would tell the motorist that you can go around blindly without even thinking. So you can't do that in a flagging operation because there's traffic coming the other way. So that's why you want to create a head-on collision.
Yeah, somebody entered a comment about sight distance into the question box.
Okay, what's the sight distance?
I think they were just commenting about sight distance being part of the answer to the question that was asked about arrows and flaggers.
Okay.
And someone just asked about handouts. We'll be emailing out a link to that after this presentation is completed.
That's right, we will. But like I said, you can also download the app and have your laptop open to either the guideline pocket guide or the temporary traffic control manual.
The same person who commented about sight distance put another comment in that said that the panel blocks the view. So I think that's pretty much what you had said as well concerning
you can see this thing at the top right that I keep moving around?
No, we can't see that. But we do see the arrow board there, and the person who had commented about sight distance, why the panel shouldn't be used with a flagger at the same time, amended their comment to also include that the panel would block the view of the flagger. Someone did ask about what the app is that we have, and I'm going to put links to our work zone traffic control app in for both the Apple App Store and the Google Play Store in the comment area.
Well, if you go to your search, when you open up where you get your apps,
right?
Type in ODOT Flipbook. I think that's what they call it, ODOT Flipbook.
I'll put the link in the box for them too.
Sometimes the link doesn't work on the newer.
Nope, I've got the right link. I'll drop it in there. So, all right.
But if you have the newer Samsung phone, sometimes that link doesn't work. So if it doesn't work, then type in the search box ODOT Flipbook or ODOT Workzone, and you'll see it. It's an orange colored app. Okay.
Thanks, Ray.
So also, if it's arrow panels are high intensity, so at night or bad weather, we need to put them on low intensity. And as I was showing you in the typical applications, there are different modes of operation. So if you're going to go out and purchase an arrow board or 2 or 3, you make sure that they're capable of all these different modes of operation, because these different modes are called out in different typical applications. So arrow left, arrow right, double arrow, and 2 modes for caution. But the 4 corners caution is the one that's called out in the typical application. So you should use that. The reason for that is there's actually been crashes in mobile operations where they use the straight line for caution, and then the motorist thought that it was supposed to be an arrow, but the bulbs in the head of the arrow were burnt out. So they just assumed that and went around and caused a crash. So that's why you should use the 4 corners mode, another reason. So here's some shoulder work. So typical application number 4 and number 6 involve shoulder work. So when you're working on a shoulder, you want it on caution mode. So you don't want the arrow mode, because that gets misinterpreted by the motorist. They think that they can't use the lane adjacent to you. And sometimes we need every lane open for capacity. I like to tell the story about one of the worst traffic jams in Columbus history was when there was a contractor out on I-70 on the west side by 270, between 270 and Wilson Road, and they were given strict orders to not work during rush hour, but they decided to work anyway. It was a shoulder operation, and they were told to, in their maintenance of traffic plan, it showed the caution mode to be used, but instead they used the arrow mode. So it was morning rush hour, and they had the arrow turned on. And just as I said, people thought that they couldn't use the right lane, even though they could. And so during rush hour, that eliminated one of our inbound lanes and turned I-70 into a parking lot. And of course, there were several rear-end crashes that go along with that. So,
Ray, I have a question. Someone would like to know, what are cautions 4 and 5?
Cautions 4 and 5. Yeah, caution 5 is shown in a lot of the mobile operations and shoulder operations. So that's the 4 corners. Okay, 4 is a different kind of caution mode, but if it was up to me, I would never use that. Like I said, it's not even shown in any of the typical applications, but I see it being used a lot. Here's an example of an arrow mode. This is a mobile operation on a multi-lane road, so that goes along with typical application number 35, where it shows it's you need to have have it in arrow mode. Then we have our portable changeable message signs. These enhance the safety of the advanced warning area. ODOT uses portable changeable message signs, but I see them used by locals as well. A lot of times, ODOT uses them to reiterate one of the required advanced warning signs, like right lane closed ahead. But you can make these say anything, and they come in handy for unexpected traffic situations. This sign here says crews working in the road. Anytime you use a sign that lets the motorist know that the crew is actually out there working, you're enhancing the safety, because the studies show that if motorists are told that the workers are present, then they behave better. So, there's not just portable changeable message signs where you can say this. There's actual, optional signs to place with your other required signs to say workers in roadway and things like that. So these are becoming more common as well, portable traffic signals, and there's a section in Part 6 of the manual all about the portable signals and also automated flaggers. But as you can see in this picture, it's a 2-lane road. A lot of times, for instance, a bridge on a 2-lane road, we can work on 1 lane at a time, and then we can keep a lane open, which is, if it's an important 2-lane road, we need to maintain traffic if we can. And instead of having flaggers out there 24/7 for a month, we can use these portable traffic signals. So the visibility of our devices is the key for effective communication and safety. When we're placing our signs and cones, you want to make sure they're visible from a distance. So we do have some devices that help improve our visibility. So we have emergency flashers, flashing strobe lights, rotating beacons, retroreflective vehicle markings. ODOT in the last 5 or 6 years, they've pretty much put retroreflective vehicle markings on all of our vehicles. When I travel around teaching this class to the locals, I usually have a minivan, and the minivans even have the retroreflective vehicle markings. They help improve visibility and decrease the odds of a rear-end crash. But these devices are usually called out in the notes page. Like in mobile operations, there's a note that says you shall use high-intensity rotating strobe lights on your shadow trucks or work trucks. Then we have some other devices that improve safety, like fencing and cover plates. Let's see what they look like. So here's what's called high visibility collars for fencing. You can use these in areas where you might have a high presence of pedestrians or bicyclists. If you definitely, if you like maybe a trench you don't want pedestrians and bicyclists driving into or walking into, you can surround it with this fencing. Then we have our steel cover plates that are very common. When I was at the City of Columbus, we had a policy in place that anytime we used a steel plate, we would have the steel plate ahead signs, and we would also put a lip of asphalt around the steel plates or even bolt them into place. It's important to provide warning to the motorists, not just motorcycles, but all motorists. They don't like to hit steel plates by surprise. So sometimes we can't get our trenching or excavation jobs complete in one day. We have to, we're not allowed to work 24 hours, so we got to put a steel plate over it. And but you want to make sure you use a steel plate that can support that particular traffic load on that street. And so it's, if this is something that your agency routinely does, then get a hold of your sign shop or your sign vendor and order the steel plate ahead signs. And here's another traffic control device: pavement markings. Sometimes in our long-term work zones, we remove permanent pavement markings and install temporary pavement markings. So maybe some of you just took my traffic signs and pavement markings course, so this is old news to you. But we have different colors and of pavement markings. Here's white markings. That what do? They separate traffic flowing in the same direction, like this dash line you see, but a solid white line would be on the right edge of the pavement.
Okay, Ray, don't forget we've got more poll questions.
All right, let's have one.
Okay. Which one do you want?
Surprise me.
Well, how about something that you've covered?
Yeah.
So you tell me which one you want.
I don't see them, so
Okay.
Just go in order or something.
How about minimum merging taper length, buffer space, long-term stationary work?
Yeah, let's see if how many of them have learned how to use their those tables that I talked about.
Okay,
so let's go with that merging taper.
All right, I'm going to launch it. What's the minimum merging taper length for a lane closure on a multi-lane roadway with a 35 mile/hour speed limit and a lane width of 12 feet?
So remember, class, we don't have to guess. So this is shown in the table, that bottom table I showed you, length of tapers. It's a merging taper, 35 miles per hour.
They must all be looking it up because they're not voting very fast.
Oh.
Only up to like 20% so far, but as soon as they all look it up, it'll all just come in fast and furious.
All right, give them 5 more seconds.
Okay, I got a countdown.
Okay.
It's like watching a horse race, watching the percentages increment up. All right, I think we're pretty well there. So I'm going to close this down and share the results. The results are in. 6% said 205, 21% said 125, 57% said 245, 4% said 540, and 12% said 180.
All right, so here's the answer on the screen. Here's that bottom table.
Hold on, they can't see that.
Oh, they can't?
So, no, I gotta hide my response.
Oh.
Now they can see it.
All right, page 17 of the pocket guide has those 3 tables. Here's the bottom table. It's also in the app. If you click on spacing, you'll see this. Spacing and tapers, I think. But if we look on the left column of this table, we see 35 miles per hour. And then we go over to the 3rd column, which says merging taper. It says 245 feet, so that's your answer. All right, so do you want another question?
It's up to you.
Go ahead.
Do you want to do the recommended buffer space?
Yeah, let's do a buffer space. Now
Okay.
they know where the table is.
All right, what is the recommended buffer space length for a work zone located on a roadway with 35 mile per hour speed limit?
You know, a lot of city streets are 35 miles per hour, whether they're 2-lane or multi-lane. So
people are voting a lot quicker on this one than they did in the last one.
Okay. All right, 5 more seconds.
Okay. 5, 4, 3, 2. Get your votes in. 1. All right, I'm going to close it out.
All right.
I think you're going to have to share that table. Answer. Well, 39% of them chose 200. 18% chose 115. 41% chose 250. And 2% chose 255. So I'm going to hide this so you can give the answer.
All right. Okay, can you see?
We can see.
All right, so here's that bottom table. I think they're having trouble downloading the app or downloading the pocket guide or something. But here we see 35 miles per hour on the left under speed limit. And then we go all the way to the far right where it says flagger station and buffer. So buffer space. So what's it say for 35? It says 250 feet. So 250 feet is the stopping sight distance. You know, that comes into play a lot with different things in the public right of way. Like, for instance, if you're a traffic engineer that's in charge of approving driveways on an arterial street, well, if the arterial street is a 35 mile per hour speed limit, then your driveways need to be a minimum of 250 feet apart. And that's because you're creating conflicts, turning conflicts and things like that. So that's another example where stopping sight distance comes into play. Okay, so back to our pavement markings. Yellow, it's the same way with signs, and the fact that yellow means warning. And so we're separating traffic flowing in opposing directions. Or if you're on a one-way street, it would mark the left edge of the pavement. And so temporary pavement markings are needed for long-term jobs most of the time. So we have to completely remove the permanent pavement markings, so a clear path is obvious to the motorist. And so there's only a couple of ways to completely remove permanent pavement markings, and that's we have to obliterate them. There's a word for you. And so how do we obliterate them so that they're not identifiable under day or night wet or dry conditions? So we have sandblasting and grinding. So we have to completely remove the marking and the glass beads, and does not leave a scar that could be misleading. And so we're not supposed to use black paint. The manual says you shall not use black paint to cover them up. And you are permitted to use, when we're putting down temporary, you're allowed to use preformed tape. So let's do some bad examples here. So here's what, if you covered up pavement markings with black paint, this is what it would look like. So it can be misleading and cause driver confusion. So there's a section in the manual that talks about that, OMUTCD section 6F.71. So the 6 means you'll find it in part 6 of the manual. Then when you open up part 6, you would look for F.71. Remember, there's 9 parts of the manual, so that is not permitted. And here's what it looks like if you just sort of halfway removed them. So as you can see, it still looks like the pavement marking's there. And so that causes driver confusion. So again, we need to grind them off or sandblast them off. So we talked about a whole lot of different temporary traffic control devices in that part. And to summarize that, our traffic control devices are the best way to communicate a clear message to the motorist. They are extremely effective if we use them properly, meaning by the way they're shown in the manual. They do help make your work site as safe as possible, and make sure, again, I can't stress enough that as we get later on into our different, maybe I'll be asking you to design a work zone in a particular situation. You don't just look at the picture in the typical application. You need to read the notes page, because in the notes page under standards, guidance, and option, there might be other temporary traffic control devices that you need to use. And so that's, and then we need to follow the standards for uniformity. The word uniform is in the manual for a reason, because anytime we're dealing with traffic control, we need to follow the standards for uniformity, and that's nationwide uniformity, so we can meet the driver's expectations. Okay, so we've gone over a lot of general information about work zones and resources and websites and manuals and standards and apps and all that stuff, and talked about the different temporary traffic control devices that are shown in each of our typical applications. So now let's start to get down to the nitty-gritty of talking about actual work zones, right? So let's start to look at some different traffic control plans and how these traffic control plans are made up of different elements or parts, and how each of these parts are tied together to form a system to move traffic around us safely and efficiently. So we define our temporary traffic control zones as the entire section of roadway between the first advance warning sign through the last traffic control device where traffic returns to its normal path. So here are the 4 typical components of a temporary traffic control zone. If you're the motorist approaching a lane closure, you're first going to arrive at the advance warning area where our signs are located, usually a series of signs for a lane closure. Then we arrive at the transition area, which usually there's a taper there to move us over from one lane to the next. Then we arrive at the work area, which consists of the buffer space, then the workspace, then the traffic space. The traffic space is the motorist in their lane. That's the traffic space. And then we have the termination area, where a lot of times we have another short taper that directs traffic back into their normal lane. And then you might see a sign that says end road work in the termination area. So if we're setting up a flagging operation on a 2-lane roadway, this picture here designates all the different elements of the flagging operation. So at the bottom of the screen, you see the advance warning area where our signs are located. And in the transition area, the flagger will be standing at the beginning of the cone taper. And then that particular taper, we learned from those tables, is 50 feet to 100 feet in length. And then we have where the taper hits the center line, between there and the actual workspace, which is this yellow hatched out area, you'll see this vacant area where there's no cars or trucks or equipment or materials. It's completely vacant. It's called the buffer space. Then we arrive at the workspace, and then over here on the left is where the traffic is driving. That's the traffic space. And then our termination area at the top, you see another short taper, and then there'll be another sign that says end road work. That sign is actually required in a flagging operation so that the motorists know that they no longer have to be on the lookout for a flagger or any other workers. Let's talk about the advance warning area. So every temporary traffic control zone has an advance warning area. Even if you're working on a very low speed, low volume residential street, you know, that might be just one sign in front of your work crew, or it might be your high intensity strobes turned on. That would be your advanced warning area. But then, you know, in this class, we want to focus on your arterial, your higher volume streets of that your agency owns. You know, so multi-lane roads, but also, you know, a lot of two-lane roads are high volume. So, you know, we're focusing on those in this class. So what do you need to do when you're working on those roads, your higher volume roads, or high speed roads, or even roads with sight distance restrictions? That's when we have to use everything that's shown in the typical applications. If we don't provide the necessary advance warning, then we run the risk of surprising the motorists, which we never want to do. And if they're surprised at our lane closure, then they might be slamming on the brakes and turning their steering wheel and some maneuver trying to avoid a crash, and then they crash. So remember, we're dealing with the laws of physics here. Motorists cannot stop on the dime, and so we need to provide the proper advance warning and use all the uniformity with that advance warning area. A series of signs, the size of the signs, the spacing of the signs, the retroreflectivity of the signs, all of that stuff. Very important. If we were to look back at our work zone crash statistics, you know, we'd probably run into a lot of times where the work zone crash could have been avoided if proper advance warning and the proper taper, you know, the proper transition area and the proper buffer space would have been in place. So we can go a long ways in lowering the number of work zone crashes and the severity of work zone crashes if we do not skimp. You know, I can't stress this enough for our roadway maintenance crews and utility maintenance crews. You know, we don't skimp on the number of signs that are required or the number of cones that you need in the taper or the buffer space, because you're putting yourself in harm's way, but also putting the motorists in harm's way. We want everybody to be safe, and if we just set up our work zones, you know, and maybe think about if we're on, you know, high speed or high volume roads or sight distance restriction areas, you know, make sure we don't just use the standards, use what's listed as guidance and options as well. We can, you know, enhancing the safety of our work zone, we're going to cut back on the number of these crashes. So one of our quiz questions had to do with this, but here we have the size of our advance warning signs. You know, if you're working on an ODOT freeway, then our advance warning signs need to be 48 by 48, and then once you get into lower speeds like 35 and lower, 40 and lower, you can use 36 by 36. You know, and maybe if you're on a low speed, low volume, 25 mile per hour residential street, then you could get by with 24 by 24. But if I was in charge of buying signs, I would never buy a 24 by 24 inch sign. 36 by 36 would be what I would use. So this table reiterates those requirements. let's take a look at some different typical applications and what the advanced warning area looks like. You know, if we were to open up the temporary traffic control manual and look at typical application number 33, you would see the illustration on your left. It actually shows, you know, a right lane closure on a divided highway. So there's a median involved here. You got 2 lanes going northbound, 2 lanes going southbound, and there's a median in between. So that's a divided highway. So ODOT crews work on this type of road all the time, right? And then we have the picture on the far left is showing long-term and intermediate. So that's, you know, that is referencing the work duration. So in that case, you're dealing with, you know, overnight and possibly longer than 3 days. So what are they doing that's different than the one on the right? Well, if you look closely, you would see you know, temporary white edge lines being placed along the taper. You might even see other things like concrete barriers in use in some places. And then on the right, we have our short term. So it's referring to usually typical roadway maintenance activities. Maybe they're working on a pothole on the far right. And but you can see in this advanced warning area, since it's a divided highway in multiple lanes, we have our signs on both sides of that divided roadway. So in the picture on the right, you can see the signs are on both sides of this, of the 2 lanes going in the northbound direction. So it's important to have signs on both sides of the divided highway because you're going to have a lot of commercial trucks on this road. That's why it's built. It's multiple lanes for a reason, to carry a high volume of traffic, including the big 18-wheelers and wide loads and things like that. So if you have a long string of 18-wheelers, which happens quite often on these divided highways, you might not ever see the signs on the right side of the road. The 18-wheelers and larger trucks would block your view. So the normal size cars need to see the signs on the left side of the roadway. And then here's the advanced warning area for a flagging operation. Again, the flagging operation is typical application number 10. So remember that each typical application has a number, 1 through 46, and a nice catchy specific title at the top. So the flagging operation is actually called, at the top of that page, you'll see lane closure on 2-lane road using flaggers, so very specific. But here we have the advanced warning area only on the right side of the road. And they've even enhanced the signs with flags, as you can see in the picture. And those are probably both state routes that I just showed you pictures of. But as I said at the beginning of part 1 of the webinar, when you work for a local government, sometimes it's not so easy to figure out where to place your signs because you have a list of things that you see on the screen there. Sometimes it's just hard to figure out where to put your signs. So, you know, we have ODOT roads always have a nice healthy shoulder to place our signs, but it's not always the case at the local level. So city streets sometimes have parking lanes. A lot of driveways might be on the road, intersections, sight distance restrictions, commercial signs might be placed right where you want to put your work zone sign, things like that. So how do you deal with these situations? Well, I might show you some ways how not to deal with them. How's that? So you don't want to put your sign right there at the intersection, because every time someone drives in front of that sign, it's blocking the view from approaching traffic. So that's not a good place to put your sign. If you go back to the title of that table about sign spacing, you'll see that it has a catchy title as well. What did it say? It says the title of that table is Recommended Advanced Warning Sign Minimum Spacing. And so there's two weasel words in that title, recommended and minimum. So that means that, you use your judgment to put that sign in a better location so that the approaching traffic will clearly see it. So you can adjust that, either move it to the other side of the intersection, make sure you're not blocking sight distance of this motorist, or the other way. So you need to figure that out. You should be able to figure that out before you leave the garage to go out there and work. By using Google Maps, the aerial view and street view, and I'll show you how to use the distance measuring tool in Google Maps. So you can figure out a lot of things with Google Maps. Google Maps is a really good and free work zone design tool, whether you knew it or not. So part of this webinar series, I'll be showing you how to use that as a work zone design tool to prevent things like this. Okay, if you work for a city, you have your downtown arterial streets that kind of look like this picture. But one place we don't want you to put signs is right on the sidewalk. And so,
and Ray, obviously that picture was not from Ohio because there's a palm tree there. None of our folks would put a sign on a sidewalk.
Oh, I thought this was downtown Cincinnati.
Oh. You're funny.
Well, anyway, must have been one of my spring break trips. I decided to inspect some work zones. But when I was at the city of Columbus, in these areas, we would use our drums, our orange barrels, and attach signs to them and put them, in the parking lane, or that's probably a red curb right there. That's why no one's parked there. But we could put the sign there about a foot away from where the through lane begins, and that would be a good placement for that sign. As you can see in this picture, you're making pedestrians squeeze past that sign. The sidewalk is there for the pedestrians, not signs. We don't want pedestrians walking around it on this side out into the street. So we want to avoid placing signs on the sidewalk if at all possible. And again, we need to place our signs where people can actually see them from a distance. They should be able to read your sign from at least 250 feet in advance, or even more on this highway. If you use the 4-foot by 4-foot sign, they can read it from further than 250 feet. So again, we could have adjusted the placement of this sign. You don't have to be exactly on the nose of the spacing listed in those tables. You can adjust to make sure that the voters can see them. And then here we have an example where we have existing permanent roadway signs. And then we have to put looks like some long-term work zone signs. So again, we could maybe, this looks like a private driveway at the bottom of this picture. Maybe we should have put those signs in advance of that driveway, and maybe even put another one on the other side of the road that you could have seen.
Ray, we have a question about long-term work zones. Would you like me to put that up in the poll?
Let's go for it.
Okay. I'm launching it right now. Long-term stationary is work that occupies a location more than 3 days. True or false? Okay, people are voting fast and furious. But there was a pretty even split there for a hot second. It'd be interesting to hear what your answer is to this. So yes, I want to share with everybody that when we look for photos of improperly set up work zones, we try really hard not to take those photos in Ohio. Any states that the LTAP folks travel in, if we see something, we try to snap a picture and let Ray have it to use it as an example, because we never ever want to show Not that we ever find things that are improperly set up in
Well,
Ohio, but we
I
don't
think
want
in
to.
part one I was showing some pictures of from the ODOT archives,
Oh, okay.
like back in the 70s.
All right, I'm going to close the voting out
All
and
right.
share it. We have 62% that said true and 38% that said false. So I'm going to hide this, and Ray can let you know which one's the right answer.
It's true. Longer than 3 days is long term. Is that what the question was?
Hold on. I'll read it out again.
I think it was.
Long-term stationary is work that
I
occupies the
can't see
location
this.
more
I
than
can't
3
see the
days. I
question.
know. Yeah.
Okay. Yeah, so it is long term if it's longer than 3 days. I'll show you a handy dandy table, and you'll get a copy of it in the handouts. I don't know if we'll get there. We might get there today. I really got to speed up. You know, these hour and a half segments really speed by.
I know.
Okay. So that was the advanced warning area. And then we have our transition area. So these are all the different types of tapers that you see in that bottom table on page 17. Whoops, let me see here. Okay, so when you look at that bottom table, you'll see that there's different types of tapers. In the upstream, that means adjacent to the advanced warning area. So that's the upstream tapers are merging. Again, the merging taper is our longest taper. And then we have variations of that, like our shifting taper, shoulder taper, and then our flagging taper, also known as the two-way traffic taper, for 2-lane roads. And then we have the downstream taper, termination area, which is depicted in the typical applications. So the transition area, you know, usually on a multi-lane road, and emerging taper is only on multi-lane roads and for lane closures. So you'll see them in the typical application number 30 and above. So when you start at typical application number 30, you're dealing with multi-lane roadways and expressways. So you're moving traffic from its normal travel lane to another lane, and we mark this with the use of channelizing devices. And as you saw on typical application number 33's example, if we're dealing with a longer term project, then we're going to use pavement markings as well. So this picture depicts emerging taper, where it's a lane closure, and it's a gradual. That's why it's long, because it's gradual, and it needs to be that gradual, and the length needs to depend on speed. There's a reason why a roadway has multiple lanes. It's because it's designed to carry a lot of traffic, including commercial traffic. So if you look at this picture, just picture yourself in we'll say that's westbound, the westbound right lane. We're putting the pressure on you to move over into the left lane. And so you gotta, on some hours of the day or days of the week, it might be very easy to do that. But also during certain hours of the day, it becomes more complicated with higher speed and higher volumes. And so when we're using emerging taper, we have to make sure we don't skimp on the advanced warning area and the length of this taper. We don't want to install too short of a taper. It needs to be a minimum length for that speed, and also we can calculate the minimum number of channelizing devices to place in there. The motorist needs to recognize that as a lane closure, not just from the signs, but from the taper itself. And so that's a reason why we invented these tables, to help us figure all of this out. So, it's another picture of this picture here used to have animation showing the red and green cars moving across the screen, and how the red car would have to drive defensively and slow down and take its place behind the green car. That might not be how people drive in the real world, where it's like a drag race and all that stuff, and maybe generates road rage. But that's not how we're supposed to do it. We're supposed to drive defensively. But we got to give them the advance warning and proper guidance. Okay, so what else we got here? So the length of the merging taper depends on speed and the width of the lane. And so if we're dealing with high speed, if you wondered, how do we come up with those? Well, we're dealing with these mathematical scientific formulas, like the length of the merging taper in a high-speed situation is equal to the width in feet of the travel lane times the speed in miles per hour. And so again, high speed is 45 miles per hour or higher. And it says if you're in doubt, assume the facility is high speed. That reminds me of another policy we had when I was at the city of Columbus. There's several 40-mile-per-hour two-lane roads in Columbus, like Agler Road, and some other roads up there in the northeast part of Columbus. And if we were flagging in those areas, for instance, we would use the high-speed spacing of our signs instead of low speed to protect the flagger. So it was, instead of 100-foot sign spacing, we used 350. Okay, so we have to remember, here's a safety portion of the webinar. So if you're working in a lane closure, if you're one of the workers, you have to realize you're in a situation that has a potential to create crashes or accidents or generate congested conditions. A congested condition for traffic is known to generate crashes, like rear end crashes and things like that. So that's another reason why you need to follow everything about uniformity and adhering to these typical applications. And again, not just look at the picture, the illustration in that typical application. Read the notes page to see how else you can enhance the safety of that work zone with, might mention additional signs or, making sure you have the proper buffer space. Another safety note is, the buffer space exists. We're going to get to that, I think, next. So, but I think I'll save that for when we're talking about the buffer space. So the tables at the bottom of page 17, they all have you don't have to be a genius in calculus to determine the length of your taper. We've done all the calculations for you. And in this page, we created this for the local governments, because when we look at page 17 in the pocket guide, they assume 12-foot lanes for the length of tapers. But if you work for a local government, like the city of Columbus, you'll see that a lot of your travel lanes are not 12 feet wide. A 12-foot lane is usually associated with the freeway. So a lot of your traffic lanes might be 9 feet wide or 10 feet wide. And so if you're, in the downtown area of Columbus, I think there's a couple of left turn pockets are 8.5 feet wide. So.
Ray, I just wanted to let you know we have 5 minutes left.
5 minutes left. Okay. So anyway, let's get familiar with these tables. They're put together for a reason. So here's an example. ODOT workers know this by heart. The length of a merging taper in a 65-mile-per-hour freeway is 780 feet in length. But as our quiz question was, if you're on a 35-mile-per-hour street, if you're in an 11-foot lane, it's 225 feet. 10-foot lane, 205 feet. So it's different, or if you're in a 12-foot lane, 245 feet. It's kind of blocking that there, but it varies with the width of lane and the speed. So here's a picture of a merging taper down on Route 52 in Lawrence County. Okay, then we have our low speed. They actually have a different formula for low speed, WS squared divided by 60. So that means width of the lane in feet times speed in miles per hour. The speed is squared divided by 60. And so why do we do that? Well, I mean, we have lots of low speed roads at the local level. You know, we have our urban residential streets like the near east side of Columbus, for instance. We have suburban residential streets like up in Hilliard and Dublin, Gahanna, Westerville. Then we have low-speed arterial streets, and also central business district like downtown Columbus are low-speed roads. So 40 miles per hour and below, we have that's how we came up with these numbers. Okay, so arrow panels, you know, they're shown in the typical application of where to place them. But of course, the illustration looks like a state route, right? So typical application number 33, it's showing got a nice wide 12-foot shoulder to put our arrow board on. But if you work for a city, you might not have that at all. You might have a curb and gutter street. So then you would place the arrow panel inside the merging taper where it would fit as soon as it could fit in there. So that's important to know. Okay, so it's 11:30, isn't it? So this, I guess we'll break here.
Yep, pick up here next time.
The next one is scheduled. It's not for a while. You get quite a break because got so many other of these in-person trainings. So April 25th from 1 to 2:30. But we'll look at some examples of these merging tapers and how to close more than one lane on an expressway. Like I said, a lot of course, ODOT crews are familiar with closing multiple lanes on an expressway, but a lot of several cities take care of expressways through their city's boundaries, and so we need to make sure that we follow those rules and the typical applications. So we'll take a look at multiple tapers for multiple lane closures, and then what else we're going to do? Then we're going to be getting into flagging operations. You want to make sure you flag properly, not just setting up the devices, but talking about flagging, the flagger safety, and also look at mobile operations and how it's possible at the local level to combine flagging and mobile operations. And so that's about as far as we'll get next time. So,
and next time will be April 25th. So right. We look forward to having everyone on the upcoming session. And please give us a couple days to get your certificates for this session out. As a reminder, if you've watched this in a conference room with others, please make sure you do a sign-in sheet for everyone who was in the conference room and get that sent in to Ray.
Yeah, and make sure you put on there which agency you're with.
Please.
As well. And get that into me today, please. Preferably between now and maybe right after lunch. So if I don't send out those certificates today, I don't know when I'll get around to doing it. So, because I'm so busy on the road teaching this class this week. So get it out right away or I'll have to send them out without you. Okay?
All right. Well, everyone have a great rest of your day and a safe National Work Zone Awareness Week next week. And we will talk to you on the 25th. Take care.
Bye-bye.